Good morning, students. Good morning. Okay, so already I have written. So we were discussing about basic concepts of chemistry, right? So what we have discussed in the last class, we have discussed about the functional groups, right? So we have discussed about the functional groups. When it comes to the functional groups, we have different varieties of functional groups. So what are functional groups? So these are the part of a molecule where a group of atoms will be arranged in a specific manner, which is going to decide the chemical property of that particular compound. Whether I am clear? So what do you mean by functional groups? They are the part of a molecule where group of atoms will be arranged in a specific manner to give the specific chemical property of that particular compound, which is going to decide the chemical property of that particular organic compound. That's where we have the functional groups. Yes, Gauri. Then we have discussed about the functional groups. Preference. Yes, absolutely correct. We have discussed about functional groups where some of them they'll be used as a suffix and some of them they'll be used as a prefix. Very good. So suffix means like name of the molecule. Name of the molecule will be ended up with suffix. Name of the molecule will be ended up with those functional groups, then they are called as suffix. Then prefix means molecule name will be started with that particular name. Yes, Stefan, that's what we have discussed with regard to different functional groups like carboxylic acid, sulfonic acid, cyanide, aldehyde, ketone, hydroxyl group, which can call it as alcohol group and amine group, right? So that's what we have discussed in the last class. Now what I will do is, I will give a table so that it will be easy for you to understand. So where in the first column we will write the name of the functional groups. Name of the functional groups. Name of the functional groups. So that will be in the first column. Second column, symbol or formula for that particular functional group. I can tell formula. Formula of that particular functional groups. Okay. Then we are going to write the name. Name of the molecule which is containing this particular functional group. Name of the molecules containing this particular functional groups. Okay. Now, since we talk about the suffix, those functional groups which will be used as a suffix. Okay, that's what we are going to discuss in first category. Now, name of the functional groups is carboxylic acid. Preference wise only I will write. So name of the functional group will be carboxylic acid. Now symbol, it can be written like this or it can be written like this. Okay, so that's where we have the symbol. Now what will be the name of the molecule? It should be ended up with oic acid. Name of the molecule should be ended up with oic acid, because we are using suffix, those functional groups where suffix will be there. So name of the molecule should ended up with oic acid. Okay. Now next one, once carboxylic acid is done, then we have the sulfonic acid. Then we have the sulfonic acid. Now what is the symbol? Symbol is SO3H. Symbol is SO3H. Okay. Now, name of the molecule should be ended up with sulfonic acid. Name of the molecule should be ended up with sulfonic acid. Okay. Then we have the next functional group which we have discussed, cyanide, right? That is nitrile group. Then we have the nitrile group. Okay. Then we have the nitrile. Yes. Good morning, Dikshit. Okay. So that's where we have the nitrile group. Symbol will be, formula will be CN. Observe it carefully. I have shown the lines. That one should be there. Okay. So we should not simply write it as CN. Okay. So don't we use that. We'll be writing the formula. Okay. That one is, you can write or you can simply mention it as a line. You can write it as R or you can simply put one line. It's understood that there is something which is attached to this particular group. Got my point? Okay, Ashish. So you can mention R or no need to mention. If you are putting one line, it's understood that there is something. If you write, no issue. But we can go with COOH. Fine? Okay. So this one, the name of the molecule should be ended up with nitrile. Name of the molecule should be ended up with nitrile. Then comes the next one. Which one we have discussed? Aldehyde, right? Then we have discussed about the aldehyde. When I am talking about the symbol, what is the symbol for aldehyde? CHO. That will be the symbol for the aldehyde. Then name of the molecule should be ended up with Al. Al. Okay, methanol, propanol, that Al. Then we have ketone. Then we have the ketone. Symbol will be C double bond O. Symbol will be C double bond O. Name of the molecule should be ended up with O. Name of the molecule should be ended up with O. Right? Then we have, after aldehyde and ketones, what else we have discussed? Alcohol, right? So we have discussed about the alcohol functional groups. Alcohol functional group or hydroxy functional group or hydroxy functional group. Okay? So that's where we can mention this one as OH. That's where we can mention this one as OH. Okay? Now, name of the molecule should be ended up with OL. In case of aldehyde, it is Al. But here it is OL. Alcohol. Okay, OL. Now, we have another group, that is amine. Amine as the functional group. Now, this one symbol will be NH2. Symbol will be NH2. Name of the molecule should be ended up with amine. Name of the molecule should be ended up with amine. Okay? Then we have the double bond. Then we have the double bond. Okay? Naturally, it will be C double bond C. Now, name of the molecule should be ended up with E. Like alkene. Alkane is single bond. Alkene, double bond. Now comes the triple bond. Now comes the triple bond. So in this case, triple bond will be there. Name of the molecule should be ended up with wine. Not W-I-N-E. Okay, not W-I-N-E. Y-N-E. Wine. Okay, alkyne. We will be mentioning it as alkyne. Right? Alkane, alkene, alkynes. So that's where these are some of the common functional groups. These are some of the common functional groups which will be used as a suffix. Which will be used as a suffix. So therefore, I have written it as ended up with. Name of the molecule will be ended up with. Okay, fine. And list has been prepared by preference wise. Least preferred one will be at the bottom. Highly preferred one will be at the top. So which is highly preferred than carboxylic acid, which will be considered as a big boss. So when it comes to periodic table, which is highly electronegative, always I used to call it as fluorine, which is a big boss. Same way when it comes to the functional group, with respect to Iupac nomenclature, you can consider carboxylic acid as a big boss. Yes, Ashish. Okay. So that's where we have the carboxylic acid, which will be having highest preference. All of you have understood? Shall I remove this? Okay. So whenever a molecule preference comes, when we have a molecule which is having more than one type of functional group, then comes the preference list. If we have only single functional group, only one functional group, no need to worry. Okay. So that's where we have discussed about those functional groups which are having or which will be used as a suffix. Then we have another category. Then we have the another category where preference is not there, where preference list is not there. Based on the alphabets, they are going to give the preference. I'll come to that. Okay. Now, first one. Now, whatever I'll be telling here, it will be with respect to those molecules or functional group which will be used as a prefix while naming the molecule. Now, first one will be alkyl groups. First one will be alkyl groups. Now, symbolically, we can simply write it as R. We can simply write it as R. Okay. Now, for example, if R is CH3, then this molecule will be methyl. Begins with. That's what I will write. Begins with. Earlier case it was ended up with. Now begins with because prefix. So aldehyde where R will be methyl, then it will be called as methyl. If it is CH2, CH3, then it is called as ethyl. Okay. So if it is CH2, CH2, CH3, then it is called as propyl. Okay, even we have the short form also. Methyl will be written ME, me. Ethyl, ET. So propyl, PR. Like that we have the short form also. Acceptable. Short forms will be acceptable. Like that it will go on. It will go on. Okay. Now if alkyl group can be a benzene ring. Alkyl group can be a benzene ring. Now it is not called as benzyl. Many students, they will get confused. They will call it as a benzyl. No. It will be called as phenyl. It will be called as phenyl. Got my point? So these are some of the examples. These are some of the examples with respect to. These are some of the examples with respect to substituent where alkyl group will be there. Then the name of the molecule will be ended up with those particular alkyl. Methyl benzene, ethyl benzene, or propyl chloride, propyl or any other molecule. So in case of phenyl, it can be phenyl propane. Like that we can write. What my point? So that's what you should understand. Okay. Now please remember, whenever this will act as a substituent to the main chain, I will talk about what you mean by main chain. So during that time it's called as phenyl group, not benzyl group. Okay? All of you have understood? Same way, if we have the halogens, then we can use this specific term like if I have the bromine which is attached, then it will be called as bromo. If it is chlorine which is attached, then we can call it as chloro. Okay? So if it is iodine which is attached, then we will call it as iodo. So what I mean to tell here is, this is where we have the list which will go on. So that's where halogens will be attached. Then with respective names, the molecule will be started with. That's why they are called as prefix. Same we have another group which is called as alkoxy group. We have called as alkoxy group. In the name itself it is there, alkyl group with oxygen, alkoxy. Alkyl with oxygen. That's why we have the alkoxy. If I want to show the symbolic this one, then I can write it as OR, alkoxy group. Okay? Now, for example, a simple one I will take. Alkoxy group is this one, OCH3, where alkyl group is CH3. Then it is called as methoxy. Then it is called as methoxy. Name of the molecule will be started with methoxy if OCH3 is attached. Methoxybenzene, one of the common molecule which we are going to discuss it later. All of you have understood? Fine. Any doubts in this? So that's what I have written with respect to different functional groups, with respect to their name, and with respect to the molecule which has to be named with respect to based on these functional groups. Any doubts? Okay, fine. Yes, Rohan. Before asking doubt, hit doubt. No doubt, sir. Okay. Okay. So then we will move to the next one. Now we will start going with one by examples. So first what I will do is, I will not take the organic compound with any of the functional groups. We will not go with any of the functional groups. First simply we will go with the hydrocarbons. How to name the hydrocarbons? Okay. Now all of us we know a 2 carbon containing molecule will be called as ethane. A 3 carbon containing molecule will be called as propane. Right? So like that we know how these, depending on the number of carbon, we can name the molecule. That one you should practice. Fine. So now we will go to Iupac nomenclature. Now we can go for Iupac nomenclature. First we will go with the hydrocarbons. First we will go with the hydrocarbons. Okay? Now I will write a molecule CH3, CH2, CH, CH3, CH2, 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 CH3. So this is the molecule. Okay? Now the question will be, write the line structure. Write the line structure. Write the line structure. Line structure and Iupac name. Iupac name for the given molecule. For the given molecule. Simply I have written even line structure as 2 marks question. So first we should write the Iupac name, right? So first we should write the Iupac name, or we should write the line structure. If I want to go with the line structure, first I should select which will be the longest chain. Same thing is applicable even for Iupac naming also. First we should select longest chain with respect to number of carbon. For example, if I take 1, 2, 3, 4, 5, 6, 7. So total 7 carbons are coming. If I take 1, 2, 3, 4, 5, 6, only 6 carbons are coming. So the first step in naming, IUPAC naming or writing the skeletal structure is selection of the longest carbon chain. Selection of the longest, which we will consider it as a main chain. That's what I was telling. So try to understand. I was telling that main chain, right? So what do you mean by main chain? Main chain is nothing but longest carbon chain. That will be considered as a main chain. So just like in a plant, biology students will be understanding. In a plant, we have the taproot system, right? Same way we are selecting the taproot. Straight line we must take, sir. It can be given in any form. It can be given in any form, but it's your duty that you should select. You should write it properly. Okay, Rohan? It's not compulsory, but for first view they will give like this, but it can be given in any way. But you have to select which will be the longest chain. Okay, now? Yes, Rohan, we will see. We will see. Okay? International Union for Physical and Analytical Chemistry. Okay, IUPAC means International Union for Physical and Analytical Chemistry. Okay, na? Not applicable, Ashish. Fine? Okay? So that's where Vishwas, not applicable, Ashish. Okay? So whether I have given the point, that's where we have the selection of the main chain. That's where I have given the selection of the main chain. So how to select, what do you mean by main chain? So this is the molecule where we have the longest carbon chain. So that and all it is there, right, for you people? 1 minute, I will check. It is there. Okay, na? So that's where we have the Iupac nomenclature. Okay, na? So when I am talking about the main chain, in this case longest chain will be this one. Longest chain will be this one. 1, 2, 3, 4, 5, 6, 7. So I have to make 7 points. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So that's why we have the 7 carbon. Main chain I have written in a line structure. Now I have to observe the branch point. I have to observe the branch point. So 1, 2, 3. So 1, 2, 3. At particular third carbon there is a branch. There is a methyl group. So this will be the line structure of for a given molecule. Okay? International, yeah, I was thinking. Yes, Ashish. International Union for Pure and Applied Chemistry. Okay, fine. So that's what. Here we have the IUPAC line structure for this particular molecule. Okay? All of you got my point? Yes, now you are right. Okay, Ashish? It's pure and applied chemistry. Yes, you are right. Yes, that is true. That's what even I was thinking. That is a different full form which I gave. Okay, now? Now that is correct, Ashish. International Union of Pure and Applied Chemistry. I told International Union for Physical and Analytical Chemistry. Okay, that is different. Okay? Yes, Ashish, whatever has given, it's correct answer. International Union for Pure and Applied Chemistry. Yes, you are right. So now that's where we have the line structure for this particular molecule. Okay, that's where we have the line structure. So 1 mark it will be given to you. Okay, 1 mark it will be given to you. But many students, they will get confused. So they will start counting 1, 2, 3, 4, 5, 6, 7. Like this up to here they will write. No. Counting should start from here itself. So this terminal indicates there is a presence of methyl group. There is a presence of methyl group. There is a presence of methyl group. There is a presence of methylene. Okay? So therefore counting should start from here itself. But otherwise many students, see, observe here. So 1, 2, 3, 4, 5, 6, 7. So that's what they will write in a hurry. Because they have started counting from here. Okay? So this will be wrong one. So it is a 7 carbon containing molecule. 7 carbon containing molecule. So there is no unsaturation also. It should be a alkane. There is no unsaturation also. It should be a alkane then. Fine. So hagadre when I am talking about 7 carbon containing molecule and it's an alkane, naturally molecule should be heptane. Molecule should be heptane. It's not IUPAC name. I am just writing molecule name should be ended up with heptane because it's the 7 carbon containing alkane. Okay, all of you have understood? Now, there is a presence of methyl group, right? Now, when I am numbering this particular molecule, when I want to number this particular molecule, now we are going with the IUPAC nomenclature. I am going with the IUPAC nomenclature. So, once again I will tell. So, Ashish has given already International Union for Pure and Applied Chemistry. That is actually correct. Okay, now that's where when it comes to IUPAC nomenclature, now listen to me carefully. Now, I have to number in such a way that, yes Rohan, you are absolutely correct. When I am numbering the carbon, I should number the main chain carbon in such a way that the branch point should have the least number. That is called as least number rule. That is called as least number rule. So what is that least number rule talks about? Least number rule tells that whenever there is a branch, yes Vishwas, International Union for Pure and Union of Pure and Applied Chemistry, yes. So when it comes to the branch, when we have a hydrocarbon chain with a branch, then we should go with the least number rule. Listen to me carefully. So we should number in such a way that you should have number 1, 2, 3, 4, 5, 6, 7. You have to write this molecule here once again if IUPAC naming has to be done. That is a question, right? So CH3, CH2, CH, CH3, CH2, 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 CH3. Okay? Now if I want to number it, it should be 1, 2, 3, 4, 5, 6, 7. If I write it in a reverse order, number 1, 2, 3, 4, 5, 6, 7. So don't think that always numbering should be done from left hand side to right hand side. No. It can be done from other way around also. But in this case, whatever example I have given, if I number from right to left, it will be a wrong numbering. That is not because from right to left we are coming. No. But in this case, whatever example I have given, when I am numbering from left to right, that will be the correct numbering. The reason is very simple. If I am numbering from here to here, I can see a branched carbon is getting 5 number, 5th number. But when I am numbering from left to right, the branched carbon is getting 3 number. Which is the least one? 3 is the least one. So we have to accept this particular numbering. And as Rohan has written, so we have to write it as 3-methyl. 3-methyl because there is a presence of methyl group. So 3-methyl heptane. 3-methyl heptane. So another 1 mark will be given to you. So 3-methyl heptane. No functional groups. Okay? So that's what? Only hydrocarbons we are practicing. No functional groups. All of you have understood? Okay, so that's where line structure and that's where Iupac nomenclature. So please remember, you should show the numbers also. You should write the numbers also to make sure that you know how to number it. You have not copied from anyone. So therefore, better to go with the numbering also, along with the Iupac name. Okay? Any doubts? Shall I go with another example? That's why we should follow least number rule when it comes to branched hydrocarbon chain. When it comes to a branched hydrocarbon chain, we have to go with the least number rule. Okay, now? So I will keep this one. So what is main chain? Main chain will be the longest carbon containing chain. Okay? Fine. The next one, another molecule I will write. You can write it, you can send the answer to me. CH3, CH2, CH, CH3, CH2, CH2, CH3. Okay, so this is the molecule. Now you should write the condensed structure. You should write the condensed structure and Iupac name for the molecule, for the given molecule. Okay, so condensed structure, don't worry, I will write. You can just send me the Iupac name. Okay, now CH3, CH2, CH, CH3, CH2 twice, CH3. Right? So that way we can form. CH2 twice I have written. Okay? So here I cannot make it as CH2 here because it is CH. This one I cannot include here. So therefore I have written separately. Then I have written CH2 twice. CH3. Okay now? So 3-methyl-hexane. Now if you observe it carefully once again, as people have written, I should go with the numbering from here to here. 3, 4, 5, 6. I cannot come from the other side. I should go from the left hand side only. So therefore it will be 3-methyl. Yes. So 3-methyl-hexane. So 3-methyl-hexane. So that's where we have the structure of the Iupac naming of the molecules. Any doubts? Any doubts? Okay. Now I will go with once again hydrocarbon only with more branches. I will go with hydrocarbons only with more branches. Okay, so with more branches. Multiple branches. Multiple branches. Okay, now in that case I will write CH3, CH, CH3, CH2, 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 CH, CH2, CH3, CH2, sorry, here on that I will stop, CH3. Okay, here on that I will stop. Okay, tell me. How to numbering the molecule first. How to numbering, which chain I should take it as a main chain. Just send me the number. What will be the main chain carbon number? Main chain carbon number. Can you send me? Okay. What is that 3, Rakesh? Earlier one you have written. So in this molecule, which will be the main chain carbon number? Just send me the number. No, Sandrita, how it can be 2? 2-methyl octane. Rohan is writing 2-methyl octane. That L-shaped, sir. Okay. With number you are right, but naming is wrong. Okay? Okay, fine, Rohan. You will come to know why or not. Fine? So as Rohan has told, if I take the number 1, 2, 3, 4, 5, 6, 7. So that is one option. How many number carbons are we are getting? 7 carbons we are getting. All of you have understood? If I number like this, 7 carbons I am getting. That's one thing. Another way is I can talk about 1, 2, 3, 4, 5, 6, 7. So in this case also I am getting 7. That means either I can go with like this or either I can go with like this. Now I can see for other options. So what I will do is 1, 2, 3, 4, 5, 6, 7, 8. Okay. I am getting one number more here. Now I am getting 8 carbons over here if I number like this. This is one option. Okay, I will keep this one as it is. Okay. So I will write the same molecule. CH, CH3, CH2, 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 CH, CH2, CH3, CH3. Okay. Now this is one option. I am getting 8 numbers. Same way 1, 2, 3, 4, 5, 6, 7, 8. Okay, in this case also I am getting 8 number. So I can have 2 ways of selecting the main chain. Either like this or either like this. Okay, but both will be same. No difference in their IUPAC name. Now if I go with this one, now whether numbering is proper? Yes, no doubt numbering is proper. That is because if I start from here, then I will get first branch at 3rd carbon. But here if I am starting at 2nd carbon itself, I am getting the branch. So once again, least number rule. So if you go with numbering like this, then I am getting at 2nd carbon only one branch point is there. But if I numbering from here 1 to 8, but at 3rd carbon I have a branch. So I should follow least number rule. So whatever numbering I have done, it is correct. Now if I want to name the molecule, I can write it as 2-methyl. There is a methyl group. And once again there is a methyl group at 6th carbon. So therefore I can write it as 2, 6 dimethyl. 2, 6 dimethyl octane. 2, 6 dimethyl octane. All of you have understood? Okay. Now we will see what will happen if I go like this. Right? So here also we can observe this is the correct way of numbering. Because if I start numbering from here, at 3rd carbon I am getting the branch. So therefore if I start from here at 2nd carbon itself, I am getting the branch. Least number rule policy. So therefore here also we have the numbering which is correct. Now I can mention it as 2 and 6. 2, 6 dimethyl. 2, 6 dimethyl octane. 2, 6 dimethyl octane. Now if I want to write the line structure, then I should write it as 1, 2, 3, 4, 5, 6, 7, 8. So total 8 carbon, right? It's the octane. So 1, 2, 3, 4, 5, 6, 7, 8. Fine. Now at 2nd carbon, there is a methyl group. right? And at the sixth carbon there is a methyl group. So 1, 2, 3, 4, 5, 6. So at sixth carbon also there is a methyl. That's where we have the line structure. That's where we have the line structure for this particular molecule. If I want to write the condensed structure, then I can use 1, 2, 3, 4, 5, CH2 5 times, right? So that means CH3, CH, CH3, CH2 5 times. Then we have 1 minute. Oh, here we have one CH group. Here we have one CH group. CH2 thrice. This is the way. Okay, all of you have understood? So that's where we have the line structure, condensed structure, and Iupac nomenclature. We have the Iupac nomenclature. Fine, all of you have understood? Normally line structure they will ask. Okay, all of you have understood? Any doubts in this? So we have gone with multiple substitution but of same type. But of same type. Same type of substituent. In this case we have gone with the methyl group. 2 times it was present. We will go with the next one. Multiple substituent where different alkyl groups will be there. We will go with the next one, that is multiple groups with different alkyl groups. CH3, CH2, CH, CH3, CH2, CH2, CH, CH2, CH3, CH2, CH3. 1 minute. Okay. So this is the molecule. This is the molecule. The given molecule is this one. You should write the line structure and Iupac name for the molecule. But before going for the Iupac line structure, first we should confirm what is that Iupac name. Just tell me what will be the parental carbon number or main chain carbon number. Say I am using the word parental carbon or main chain carbon, one and all same. Taproot system, right? So what is that parental carbon number? Sir, can't we take leftmost CH3 as first, sir? Okay, I removed that. Now whatever we have done, that will be the correct one. Even leftmost you can take. But another methyl group will be used as a branch. One and all same. So 2,6-dimethyl octane. Okay, fine. So what is the parental carbon number here? Just mention hexane, heptane or octane, nonane, what it will be. Anyone? 2, 6, okay, earlier one only. Just tell me. Okay, Gauri is telling octane, Sandrita is telling 7. Okay, any other answers? Hexane, Ashish is telling hexane. Now I can tell that Gauri, she is right. Now Shashank has given name itself. Okay, we will see. Shashank as a parental carbon octane, it is correct. Gauri and Shashank, both of you are correct. It should be a octane. Rohan, it cannot be a heptane. It should be a octane, 8 carbon containing molecule. Okay. For example, I will go with numbering 1, 2, 3. Don't write this one. 4, 5, 6, 7, 8. So 8 carbon I am getting. If I go like this, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So that means this is not preferred. Okay. Now I will consider another way round. 1, 2, 3, 4, 5, 6, 7, 8. That is fine. That is also fine. So 1, 2, 3, 4, 5, 6, 7, 8 like this, or 1, 2, 3, 4, 5, 6, 7, 8. So like this or like this, anything is fine. In both the cases we are having 8 carbon. So parental carbon is 8. That is octane. It should be a octane derivative. It should be a octane derivative. Now, the question here is whether whatever numbering I have done, rule, what I will do is anyone we will select. I will select this one, straight chain. It will be easy for you to make understand. Okay, I will remove another one, but another one is also correct, no doubt. Okay, so whatever numbering I have done, whether it is correct, whether it is following the least number rule, yes. For example, if I go with like this, at third carbon there is a branch. If I go numbering like this, at third carbon there is a branch. So in both the direction, if you number exactly at third carbon, we are going to have the branch. Gauri, wait. At third carbon, we are having the branches. Now, least number rule, okay, fine. Least number rule, it is following, okay, fine. Now we have additional point. Listen to me carefully. We have additional point. Least number rule should be applicable when we have different types of alkyl substituents. Then least number rule should be applicable in such a way that alphabetically preference has to be given. Alphabetically preference has to be given. What I mean to tell? In this case, we have methyl and ethyl. Which one will come first in English alphabet? Methyl or ethyl? Naturally, A, B, C, D, E. Ethyl will come first. And at the end, methyl will come in. All of you are getting my point? So when we are having different types of substituents, different types of alkyl group as a substituent, then we should follow alphabetic preference. Least number rule only, but we should give alphabetical preference. Naturally, yes Ashish, E will come first compared to M, because we have methyl, then we have ethyl as the substituent. Alphabetically, ethyl will come first. Since in both the direction we are having a third carbon as a branch, so what I will do is, I will number from the right to left side. I will number from right to left side. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Why I am numbering like this? Because at third carbon there is an ethyl group. E comes first alphabetically. So therefore, even while naming, I will name it as 3-ethyl. 3-ethyl, 6-methyl, octane. Got my point? So 3-ethyl, 6-methyl, octane. Why we have numbering from right to left? Because in both the ways, whether you follow like this or whether you follow like this, at third carbon there is a branch. So therefore in that case I will go with that direction where I am having alphabetical preference. Got my point? All of you have understood? Any doubts in this? Okay na? So in that case, if I want to write the line structure for this, first I should write the 8 carbon. First I should write the 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. I should write the 8 carbon. Now at third carbon there is a ethyl group. So that means 1, 2, 3. So there is a ethyl group. So this line, this corner indicates CH2, This one indicates CH3. Then at sixth carbon, that means 1, 2, 3, 4, 5, 6. Another methyl group. We have the methyl group. That's where we have the line structure for this molecule. That's where we have the line structure for this particular molecule. All of you have understand? Okay? Any doubts? Shall I give some another example based on this? Fine? Okay? So that's where we have the IUPAC name for this particular molecule. That's where we have the IUPAC name for this particular molecule and line structure for this particular molecule. Okay. So in that case, I will write another molecule, CH3, CH, CH3, CH2, CH, CH2, CH, sorry. CH2, CH3, CH2, CH3. So this is the molecule. 1 minute. So this is the molecule. Okay. So how to number this molecule? Just send me parental carbon. Just tell me parental carbon number. Just send me the number. Parental carbon or main chain carbon. Number you should tell me. Okay, according to Gauri it should be hexane. All of you will agree? According to Gauri it should be hexane. She removed. She deleted hexane. What you want to write, Gauri, now? Yes, now you are right. It should be 7. It should be 7. It's not hexane. It should be heptane. All of you right. It should be a heptane derivative. Okay? So in the beginning, Gauri she has written as 6. I was surprised. Then immediately she deleted that message. Okay? Then I was knowing that she will make it correct. So that's why it is a heptane. Okay? Now, if I give the numbering, so 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. One and all same. Okay? So therefore, 7 carbon containing molecule. So therefore, it should be a heptane. Now, if you observe it carefully, whether my numbering system is correct or whether whatever I have numbered it is correct, can you observe? Yes or no? Whatever numbering I have done, it is correct or it is wrong? Anyone? Okay, Ashish is telling it is correct. Anyone else? Ashish is telling whatever numbering I have done, it is correct. Because if I go with another way around, I will get 1, 2, 3, 4, 5, 6, 7. Another way around. Reverse if I come, it will be like this. So now observe it carefully. This will be a wrong one. Because if I go like this, I am following least number rule. But if I am following like this, I am not going with least number rule. So what is that least number rule? So at second carbon plus and at fourth carbon. So total answer is I am getting 6 if I go like this. Second carbon there is a branch, fourth carbon there is a branch. 4 plus 2 is 6. If I come like this, at fourth carbon there is a branch and at sixth carbon there is a branch. That will become 10. So this should be wrong. I should follow with first one. Least number rule policy. Okay? But Rohan, Rohan. But when you are naming the molecule, alphabet should be given the preference. When I am naming the molecule, alphabet should get the preference. So therefore, I will mention this one as, this is not the proper numbering. Upper one will be the proper numbering. So I should mention this one as 4-propyl. A B C D F G H I J K L M N O. Okay, sorry. Rohan, you are right. It is methyl, right? Okay, it is methyl. So you are right. Rohan is right. It will become 2-methyl 4-propyl 4-propyl heptane. Okay, that's where we have the numbering and naming of the molecule. Rohan, you are right. So I was thinking something else. So it is methyl. M1 will come first. After that, P will come. Okay. So therefore, 2-methyl 4-propyl heptane. Now what will be the line structure? 1, 2, 3, 4, 5, 6, 7. So 7 carbon. And at second carbon there is a branch. And at fourth carbon, 1, 2, 3, 4. That means that fourth carbon there is a propyl. At fourth carbon there is a propyl. So that's how we can write the propyl. All of you have understood? Okay. So that's where we have the line structure for this particular molecule. Any doubts? Tomorrow anyway, we are going to solve some more problems based on this. Fine. Any doubts up to here? Today's class, any doubts? And once again, IUPAC, okay, it will be International Union for Pure and Applied Chemistry only. I was telling something else. Okay, now? So it is International Union for Pure and Applied Chemistry. Okay, now? Thank you. Thank you then. So tomorrow we'll solve some more examples. Fine? Thank you. You can practice whatever I have solved. Okay? Thank you. Thank you everyone. Take care.